Hello, everyone, and welcome to the introduction to calculus. So, here, don't worry, we're not going to talk about the whole history of the ideas and topics that are part of calculus by those who are inventors of these topics or ideas. All right, because uh, in this history, we're just going to uh, talk about the two brilliant inventors who introduced us calculus. Although there were some mathematicians, philosophers, or scientists that also contributed an idea, or if not one, ideas that is also or that are also part of calculus, right? So before in the ancient times, there were some philosophers, mathematicians, or maybe scientists who invented an idea, or maybe not invented. Maybe that sounds wrong. Maybe formulated, much better. They formulated an idea or topic that is part of calculus today, but they have no idea that this is a lesson or topic that is part of calculus. So they have no idea. And there were some scientists, mathematicians, or philosophers, once again, that after calculus was invented, they have they had formulated an idea that will contribute to that subject as well. But uh, let's just say that we're going to focus only these two inventors who really introduced us calculus. Okay, so we're not going to talk about those people before calculus was invented and after. We're just going to talk about these two inventors. And these are Isaac Newton and Gottfried Leibniz. So let's talk about Isaac Newton. Isaac Newton was born on the 25th of December in 1642 and died at 20th of March in 1726 or 1727. There's a conflict in this year because in here there's a conversion of calendar system at that time. He's planning to, not planning to, wait, forgive me. What I'm trying to say here is that at that time, they're converting their calendar system from old calendar system to a new calendar system. So there's a conflict here. All right. He was born in England and he's an English person. So here, according to the source, he was the first person to apply calculus to general physics. And he published Method of Fluxions. Method of Fluxions is the earliest written formulation of modern calculus, completed in 1671, published in 1736. The fluxion is a term for derivative. Derivative, to give you a spoiler, is one of the topics that we will discuss in the future. All right. You see, Isaac Newton, he invented his calculus because of the apple. You see, just imagine that this is the apple tree. And let's just say this is Isaac Newton. I couldn't draw a person sitting down. So just imagine that he's sitting down here. Now, there's a debate whether the apple hits on his head or just beside him or basically on the floor. But despite where the ball falls down, or yeah, where the ball fell down, sorry if the grammar's wrong, this scenario made Isaac question. So here was his thought. If everything falls down, why does the moon not fall? Because you see, the apple fell down, which obviously makes sense because it's on the top. So once maybe there's some what do you call this one? Some forces that made the apple, fell down. So yeah, it will fell down. That's it. That's basically what do you call this word? The natural and common thing that we humans observe and do, like jumping, right? We jump, we go up, then we go down. But if that's the case, then why does the moon not fall? So because of that, he invented calculus to figure out this unexplained phenomenon for him, right? And because of that, he published method of fluxions. So that is for Isaac Newton. Now, for Gottfried Leibniz, full name, Gottfried Wilhelm von Leibniz. By the way, please correct me if the way how I pronounce it is wrong. He was born in the 1st of July, 1646, and died at 14th of November in 1716. He was born in Germany, so we can say that he's a German person, or German. So in this source, he actually developed the notation used in calculus today. I'm going to introduce to you later what notation is used. Okay. Here, he publishes Nova Methodus Pro Maximis et Minimis. There's a end quotation here. Forgive me if I did not include. But yeah, he publishes Nova Methodus Pro Maximis et Minimis. This is basically in English for a new method for maxima and minima. So this is about maximum and minimum of anything. So here, yeah, we're going to talk about the notation in modern calculus, which is right now. And due to that, because of his, let's just say, notation, it implies that his work or contribution to calculus was much more influential than Newton's. So that is for Gottfried. Now, here is the question. Did they work as partners? The answer is no. So if that's the case, then how did they come up with these ideas? Well, to answer that question, they figured that out on their own. Okay? They discovered, formulated, and figured that on their own. Just like for Isaac Newton's and for Leibniz, forgive me, and for Leibniz. And now, due to that, there was a heated debate, right? There was a heated debate. Because at that time, Isaac never knew that there was a person who also planned to invent calculus because, wait, no, not because. Yeah, basically, Isaac Newton never realized that there was actually a person who invented an idea that is so or extremely similar to Newton's. So because of that, there was a heated debate. So they were like, okay, wait, this is my contribution. How did you come up with yours? Wait, that's impossible. This is mine, and blah, 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 and blah. Right? So there was a heated debate. So here, Leibniz publishes Nova Methodus Pro Maximis et Minimis before Newton published his result, which he had first derived and later published in his method of fluxions. You see, that's why in his biography earlier, right, he published method of fluxions, right? I mentioned that it's the earliest written formulation, but it was not the first book published, because the first book published for calculus is this one. But the earliest formulation is the method of fluxions. Okay, if Newton published it earlier than Leibniz, then method of fluxion is the first published book. But no, it's just a earliest written formulation. All right. So you see, despite the what will happen if Newton published this first before Leibniz, so on and so forth. Still, you see, Leibniz published this book, and then later Newton published his own book about calculus. Because of that, Newton began to question Leibniz, like, where does his work come from? He even actually claimed that Leibniz plagiarized his unpublished notes, because you see, before he published his notes, he actually shared his work to a group of Royal Society members before he, what do you call this one? He published that book, or his book rather. So yeah, it's debate. So there were English mathematicians and foreign mathematicians from European counterparts that needed a, let's just say, how should I say this? There were mathematicians, English and from European, to come up with a conclusion of which of these two should be credited. But you see, the conclusion, after many years of this debate, they arrived their conclusions independently. That means it is just a coincidence. You know, it's like, for example, I'm making my own sport, let's just say volleyball. Then suddenly there's another guy who also planning to invent volleyball. And I thought that he's just plagiarizing me. But then I realized, oh, maybe we're planning to invent volleyball. It's just that we just do it by ourselves. We don't do it by partners. We don't do it, like, let's just say we work together. We just basically started by our own, So that's what happened between the two. Because you see, Leibniz started with integration, which is another topic that we're going to discuss in calculus. And we have differentiation for Newton. So this implies that it is just a coincidence. It is just a coincidence that these two come up with their own idea or formulations that is part of calculus, or that are part of calculus. So to sum it up, they invented calculus. This word calculus is actually named by Leibniz. All right. Before, when Newton, published his method of fluxions, he used this term, the science of fluxions, to describe his calculus until the 19th century. So after 19th century, they used calculus instead of the science of fluxions. It took until 1815 for the first comprehensive treatment of calculus to be published in English using Leibniz notation. All right. So now that's basically the brief history of what happened between the two. So what is calculus? So calculus, according to Math is Fun, is about changes. When I search it in Google, okay, that talks about the definition of calculus. According to Oxford Languages, it is the branch of mathematics that deals with the finding and properties of derivatives and integrals of functions by methods originally based on the summation of infinitesimal differences. The two main types are differential calculus and integral calculus. All right. So that's basically it. This one is actually this definition is about, what I call this one. It's an overview of what topics involved in calculus. Then here, according to Bijus or Bijas, I'm not sure with the pronunciation, but please forgive me if I'm wrong. So Bijus, according to that website, it deals with continuous change. This is also known as the infinitesimal calculus or calculus of infinitesimals. This one talks about how functions change continuously. So why is it called infinitesimal calculus? Not to mention that according to the Oxford Languages, by methods originally based on the summation of infinitesimal differences. So let me give you a scenario of what ancient, let's just say, people do to find the volume before. All right. Let's just say you have a vase and you want to find the volume of this vase. You see, what they did here is that uh, they break this vase into two pieces. I mean, into pieces, right? From this whole into two pieces, or three or four, basically bigger pieces. Then later they made it even small. I mean, smaller than the first one. All right. Then they made it even smaller, and smaller, and yeah, smaller. Okay. Why did they do this one? Because you see, the shapes, okay, the pieces that were broken, they think that these shapes they can be formed by basic geometric shapes such as circle, triangle, square, or rectangle. Because once they found out that, for example, these small pieces, or let's just say, uh, these pieces are, oh, this piece looks like a circle. Oh, this piece looks like a it looks like a rectangle. Because of that, they can find the area. They can find the area of these pieces, or if possible, volume, so that once they found all of these areas of these bits pieces, or volumes rather, we can now find the volume of this vase. So basically, you see, uh, these small pieces represents differential calculus. Okay, right? Differential derivatives, in other words. Because you see, in derivatives, according to Math is Fun, derivatives is about cutting into smaller pieces to find how the function change. You get me? It's like this one. Okay, anyway, from big, then smaller, and then smaller, and so smaller. So they cut that into small pieces to find out how it does change. You get me? Then for the integral calculus, it's about the summation of all of these pieces. These small tiny pieces. You get me? They add those small pieces, and yeah, that's basically about integral calculus. And the summation of these pieces were very useful in getting the area. All right. So you see, I mentioned earlier, maybe this piece looks like a circle, so we can just use the formula of a circle, and we have this another bits of pieces that looks like square, so we can get the area of this one, since we know what square looks like, right? And the area of that, right? And so on and so forth. So these things are very useful in terms of getting the area and volume. All right. So later we will discuss that. So what are the prerequisites? The prerequisites, okay, is pre-calculus. You see, in my curriculum, education curriculum, let's just say Philippine curriculum, pre-calculus consists of conic sections. What's next? Sequence and series, trigonometry, then polar equations or polar forms. But in other curriculum, pre-calculus consists of topics that you need to learn before you proceed to calculus, which is that's the same thing in my curriculum. But here in pre-calculus, they do not only include conic sections, trigonometry, they also include algebra, geometry, and yeah, trigonometry, the one I mentioned earlier. All right. So what I'm trying to imply here is that pre-calculus is just basically knowing the basics of math before you proceed to calculus. So the basics of math is algebra, geometry, and trigonometry. These are the basic subjects or branches of math that you need to learn before you proceed to calculus, because whatever you learn from these subjects, you will apply that in calculus. So what are the topics involved? Well, first, let's talk about the backbone of calculus. the limits. All right. Then let's talk about differential calculus, the one we discussed earlier. And lastly, we will talk about integral calculus. Although I would like to add one more topic here, but that would be let's just say uh, it's overloaded. I mean, it's too much, because the next topic would be advanced, because this topic involves the application of both differential calculus and integral calculus. So I think that would be a different subject. All right. So I think that will be all. So see you soon, guys.